So today is our prep day for the rest of this unit. Okay? Today is our prep day for the rest of the unit. Today I need you to remind you how to do some stuff so that the rest of the unit is cake. I'm also sorry for saying cake when I don't have any cake to share with you. Sorry. Okay? We need to be able to solve a system of equations. So before we can solve it, I need you to remember what in the heck a system of equations is. Do you remember what a system of equations is? Well, just if you use your context clues, a system of equations, multiple equations, right? Multiple of equations. Now, depending on how many variables we have will depend on how many equations we have, right? How many variables do we have in this first example? 2. We have an x and a y. So how many equations do we need to solve that system? 2. However many variables we have, we need at least that many equations to solve the system. Okay? This is all stuff you did in Algebra 1, but it's been a couple days, right? So I'm going to remind you how to solve a system of equations. In Algebra 1, you talked about 3 different ways to solve a system of equations. The first way was by graphing. Okay? So let's take this system of equations that's here in front of you, and let's solve this system by graphing it. Okay? So let's graph each equation one at a time on this graph right here. Okay? No, we are not using our calculator. We're using our brain today. Don't say darn it. We can use our brain. We can do it. Okay? How do I graph this line right here? What do I graph first if I'm graphing by hand? I graph the y-intercept, don't I? What is the y-intercept? 4. So on the y-axis I go, perfect. And I put a point, right? I go up 4 and I put a point. From the y-intercept, where do I go? I use my slope, right? Remember, slope has to be a fraction? Oh, that's not difficult. 3/1. So what'd you say, Drew? I go down 3? If I go down 3, which direction do I go for the 1? Left? So I went down and negative? Oh, so down and positive, right? Because I used the negative on the 3. Now, technically, how many points does it take to make a line? 2, right? So I could stop right here. Or I could go down 3 more and right 1, and down 3 more and right 1, and down 3 more and right 1. Why would I want to do that? Could I go up 3? As long as I went left 1, correct? Because then this time I'm using the negative with the 1. Now, don't I get a way better picture of the line than if I just have those 2 points? Doesn't that look really clear, like where the line is? Oh, yeah, okay. So I'm going to draw my line real quick. You okay with that? So that one's done, right? Okay. How do I graph this one? What do I do first? Y-intercept, which is? So on the y-axis I go down 2 and put a point. And then my slope, 3/1. So I rise 3, run 1, right 1, right? Rise 3, and I want to do all that I can see. So that means that, can I go down 3? As long as I go left 1. Now we have this amazing technology in our hands of our calculator, so why am I making you do this by hand? Because I'm super evil and terrible and rude and hateful? Oh no, yeah, TSI, we can't use a calculator on TSI. I want you to ready to graph if you need to graph, yes? Okay? So, have we solved the system of equations? Well, I graphed both equations, right? So where do you think the solution is? You're telling me with your hands. Tell me with your mouth now. Where they cross. What's that technically called? A point of intersection. That's exactly right. Okay? It's a point of intersection. What is that point of intersection? 1 1. Now, without this, you don't receive all the credit for this problem. This means you know that the solution to the system is the point of intersection, and you write it. Guys, it's not good enough to be like, oh, there it is. You can't just show me, right? You have to tell me. You have to write the point of intersection. But that is the solution. Now, is there a way I could be like super sure that that's the point of intersection? Like that I did it right? Oh, I could check it, right? 1 equals negative 3 times. What's negative 3 times 1? Negative 3 plus 4? 1. Does 1 equal 1? Excellent. 1 is there, 1 is there. 3 times 1? 3 minus 2? 1. Does 1 equal 1? I know that's correct then, without a shadow of a doubt, right? Okay. Any questions on how to solve a system by graphing? What if when they give you the system, it's like in standard form? So it's like ax plus by equals c. It's in that form. What do you have to do? You have to put it in slope-intercept, right? You have to solve for y. Does that make sense? Is this starting to come back to you at all? Oh, yeah. Okay, good. That makes me feel a lot better. Sometimes when you stare at me like I have 3 heads, I wonder. Maybe it's the outfit today. I don't know. Okay. All right, are you ready for the next way? Okay, so here's our next example. Now, I have it on graph paper, mostly because I wanted to be able to use the graph paper for the top. We're not solving this one by graphing, okay? We are solving this one with using substitution, okay? So I'm going to write that right up here, substitution. So this one was graphing. This one's substitution. What do you think I mean by substitution? Like if I'm sick and I can't come, what do? They get a sub, right? They get a substitute for me. Another person that comes in here and watches you, right? Does my lesson plan, shows my videos, stuff like that, right? Okay. So what do you think we're going to do if we're trying to solve this by substitution? It seems like we would plug something in, right? So what we have to do first is decide which variable we are going to solve for, because we're going to choose one of these 4 variables to solve for, to isolate, to get by itself. Okay? Now what I always look for is the smallest positive coefficient. Which one of these variables have the smallest positive coefficient? And to be technical, you know that -5 is the smallest, right? Because it's the furthest left on the number line, but you know also that's not what I mean, don't you? Okay? Like if I was talking about the absolute value of the number, I would want it to be the closest to 0 as possible, right? So you want to choose the y. Which y do you want to choose? The top one, right? The top one because it's positive. So could I choose the bottom one? Yeah, but at some point I had to divide everything by a negative. And you know negatives are my nemesis, and that there's always places to mess up when we're dividing by negatives, isn't it? Okay, so let's choose this y right there. So in order to isolate that y, what do you think I need to do first? Add 4x to both sides. That's correct. Is everybody okay with that? If I'm trying to get this y by itself, it would make sense that I add 4x and add 4x. So what I end up with is y equals 6 plus 4x. You okay with that? Because now I know that y equals 6 plus 4x. Now I use the top equation to get that equation, right? To simplify that top equation to get to here. So I need to go the other equation, and I need to take what I know y equals, and I need to plug it in for that y. So I'm going to rewrite this equation, -5x minus 6 plus 4x, because I know y equals 6 plus 4x. Does that make sense? To 2 of you? Excellent. Okay. Oh, more? Okay, excellent. Now what? Yeah, now I want to solve this one, right? So I have -5x. Don't I need to distribute this negative to each term inside the parentheses? So -6 minus 4x equals 21. Now what? Oh, I have like terms, right? I have a negative 5x and I have a negative 4x. What is that? Negative 9x minus 6 equals 21. And then what? Perfect. If I add 6 to both sides, I get negative 9x equals 27. Now if I divide both sides by negative 9, x equals negative 3. Yes, I got an answer. I'm done, right? Oh, I'm not? Well, because I'm thinking, what is the solution to the system? What's the solution to the system? The point of intersection. I need to have my answer written as an ordered pair. If all I know is x, do I know the solution yet? No. If I have x, what do I also have to find? Y. But guys, look, I already have an equation that set y equals. Right? What's up? Yes? Good catch. I think I said it, but didn't write it. So sorry. Good catch. No, for sure, good catch. Okay? So what if I take this negative 3 and put it right there? Can I do that? So y equals 6 plus 4 times negative 3. Well, what is 4 times negative 3? So 6 plus 12 minus 12? Minus 12. See, negatives are my nemesis. I fight them every day. What is 6 minus 12? Now I'm done? What do you mean no? I know x and I know y. What is my solution? That's exactly right. My solution is the point of intersection, and I have to write it as an ordered pair. So what is my solution? Negative 3, negative 6. Is it right? Oh, yes, sir. I'm going to enter it. Negative 4 times negative 3, 12 minus 6. So it works in the first one. That's good enough, right? Oh, no, I had to check both. Okay. Negative 5 times negative 3, 15 minus a negative 6. So plus 6, 15 plus 6. Is it right? Not only do I know it's right, I'm positive that it's right now, don't I? Or aren't I? Yes? Okay, so graphing is one way to solve a system. Substitution is one way to solve a system. And the last way we're going to talk about today is elimination. I like elimination because what I get to be is a variable assassin. Variable assassin, not people, that's illegal. Variable assassin. Yes? That means I'm trying to eliminate a variable. So what we have to decide is what variable would be the easiest to eliminate. In order for them to eliminate, they have to be same number, opposite signs. Okay? So let's talk through this problem so you know what to think, or not what to think. I don't ever want to teach you what to think. Like how you should be thinking for these problems. Fair? Okay? So let's start with the x's. Let's pretend I want to eliminate the x's. Okay? If I choose to eliminate the x's, what number are both of these numbers divisible into? 15, right? 15 is the smallest number that they can both divide into, right? Not divide by, because that's definitely 1. But we're saying what's the smallest number they both divide into? So that's got to be at least as big as each one of them and maybe even bigger, right? What would I have to multiply this one by to make it become 15? 3. What would I have to multiply this by to make it become 15? 5. And I would have to have one of them be a negative because I need them the same number but opposite signs. And right now they're the same sign, aren't they? Does everybody understand that? So what if I tried to eliminate the y? Whoa, what is it doing? It's freaking out again. Let me move the blue. Let me back up. Super weird. Let's pretend we want to try to eliminate the y. What's the smallest number that the y's both divide evenly into? 6. Well, I already have one of them that's a 6, right? The bottom one's already a 6. All I'd have to do is multiply the top equation by close, -6, right? Because I need same number, opposite signs. Which one would you prefer to do? Eliminate the x's or eliminate the y's? Usually people want to choose the y's because it's only one thing to multiply by, right? Okay. So if I here's before I actually do this, I need to make sure that we have the right structure before we started. I should have said that first. We have to make sure we have the right structure. And the right structure is both of these equations are in standard form. Right? When we're graphing, we need to make sure both of them are in slope-intercept form so I can graph them easily, right? But when we're trying to solve by elimination, I need to make sure both of them are in standard form, which means the x's, the y's, the equals, and the constants. Everybody okay with that? This one just happened to be already in that structure, so I didn't even think about it. But I remember now, so I told you. Okay? So let's multiply this top equation. What did we decide by? -6. So if I multiply the top equation by -6, what does it become? -6 times -5? 30x. -6 times y? -6y. And then -6 times -2. Everybody understand? You good or no? Okay. Now, I don't need to do anything to the second equation because it's already the 6y that I need, right? So I'm just going to write it over there so they're all together. You okay with that? Yeah. So now what? If we're solving by elimination, now that, oh my goodness. If we're solving by elimination, now that I have everything lined up, now I combine them. I combine the two equations to eliminate the variable that I need gone. So I have 30x and a -3x. What do I get there? 27x. -6y and +6y? Perfect. It's what I needed to happen. I needed it to be 0, right? So now the y variable is eliminated. And then I have 12 and -12. So sometimes when this happens, what do you guys do? You panic, right? That's rule number 1. We don't panic. Rule number 1 is we don't panic. Because didn't it just become easier? Because to solve for x, don't I divide by 27 on both sides? And what's, not negative. What's 0 divided by 27? 0. Oh, we're not done. Why are we not done? We need the y. How do I figure out what the y is? Substitute. I want to substitute this x back into one of the equations. I got 4 to choose from. I got this one, I got this one, I got this one, I got this one. Which one would you choose? Y top left. The y is already by itself, isn't it? The y is already by itself in the top left equation. What, could I choose the bottom left equation? Yes, absolutely. Okay, but because the y is already by itself here, that's probably a better choice. Okay, so -5 times x, but I know x is 0, plus y equals -2. Well, what's -5 times 0? 0, so I just get y equals -2. Oh, yeah, you're right. I'm not done yet, am I? Because what do I need to do? I need to write it as an ordered pair. This means that I know that my answer, the solution to a system of equations, is the point of intersection. Does that make sense? Are there any questions? Those are the 3 types of questions that you're going to do tonight for homework. Okay? Remember, this is our prep day. You already have done all this in Algebra 1. This is not Algebra 2 material. This is Algebra 1 material, but we're preparing our brain to go on with the Algebra 1 material, or sorry, the Algebra 2 material. So would you please circle the following problems? Okay? Circle the following problems. Number 2, number 4, number 6, and number 8. Those are on the front. On the back, would you please circle number 10, number 16, number 17, and number 22. Any questions? Would you please also put a box around problem number 1? A box. Just around the number. You don't have to put it around the whole entire graph. But it's up to you. I don't care. Why did I have you put a box around that one? Because you cannot do it for bonus. Why? Yeah, that was an example, right? I already did that one for you. So you can't get extra credit for ones that I did. Got it? Any questions?